Okay, so today what we're going to talk about is called functions with exponents and logs, or with exponentials and logs. So we kind of already did these functions before, but now we're just doing them with exponential functions and logs. And so to start here, they're going to give us two different functions. Then they're going to ask us to do some operation with it. So maybe adding, subtracting, or multiplying. You can see we have some of each here. So like I said, kind of in the intro, I don't think this is going to be that hard. So all we do when it says what's g of x plus h of x, we do what's g of x plus what's h of x. Okay. So we're literally just taking those two functions that they gave us. It told us to add them together, so that's me adding them together. Now, if we have any like terms, we should combine them. But I'm actually going to say on this one, we do not have any like terms, okay? Some of you may be thinking this is 3x plus 5x, that's 8x, but that's actually not true. This is not 3x right here, okay? This one is 3 to the power of x, and this one is 5 times x. So that's not like terms. Therefore, I cannot combine them, so I got good news for you. It means we're done. So just box it up. That's it. So we cannot combine like a number to the power of x with a number times x. Those are not like terms, okay? Once again, if it was 3x plus 5x, of course, we all know that would be 8x, but this is not that, all right? Okay, so the next up here, a little bit trickier. We're going to do h of x minus g of x. So h of x is this minus, and then for g of x, since this one's minus, we need to subtract g of x in parentheses. Which we talked when we did this a few months ago. We always talked about that. We do that whenever it's minus, we use parentheses so that we can distribute the negative, okay? So I do need to distribute the negative here, so I'm going to do that. So this is going to become minus 4 to the power of x plus 2. So now we're going to combine like terms here. Now, I cannot, negative 3x to the third and negative 4 to the power of x, those are not like terms, so I cannot combine those. So I'm just going to rewrite those ones. The order doesn't really matter, so I'll go ahead and just write them like that. So negative 3x to the third power minus 4 to the power of x. However, I can combine the plus 1 and what's now the plus 2 to give me a plus 3. There we go. So a little trickier than number 1, but I'd say not really. I mean, it did involve distributing the negative. We need to be careful about that whenever it's a minus. And we did have a little combined like terms there with the 1 plus 2. All right, let's continue on here. Let's do number 3. So this one is asking us to multiply the two functions. So that's going to be 2 to the power of x times 4x minus 5. So that's one way to write it. Or I'm just going to pause here in case people just came in. I will attach the notes since Schoology's not working, so you can go grab those if you have not already. Or the other way that we can write this is if you distribute the 2 to the x there, they would probably write this as 4x times 2 to the power of x minus 5 times 2 to the power of x. So they just multiply both of those terms individually by 2 to the power of x. They usually, in those cases, put the 2 to the power of x second. A quick note though, like on something like this, 5 times 2 to the power of x, you cannot make that, that is not 10 to the power of x. You cannot actually multiply these two numbers because 2 has the exponent and 5 does not. All right. So you would always just keep those separate. Same thing here. I cannot multiply the 4 and the 2 because the 2 has an exponent. So that really just messes everything up there. Okay, let's take a look at number 4 then. So number 4 is addition. So we go log base 6 of x plus 2 plus log base 6 of x. So it told me to add together the functions, so I just add together the functions. However, remember on this one, when we have logs adding separately, we did learn that you can condense this all into one logarithm, right? When you have logs adding or subtracting. If they're both positive, they're going to end up multiplying by each other inside of a log. So I'm going to multiply the insides together. So x plus 2 times x. Well, I would have to distribute the x in there. So here's what we're doing. We're doing x plus 2 times x. So we learned in this unit that if you have adding separate logs, you can condense them by multiplying inside of one log, which I would then call x squared plus 2x, because I would distribute the x in there. So that would be my final answer on number 4. All right, next up on number 5. So number 5, it says f of x minus g of x. So we'll start off by subtracting these. However, we did learn another rule in this unit, in this chapter, that says when the two logs are separated by subtraction, we can condense them into one logarithm. And inside the logarithm, they are dividing. And then we have x to the third over x to the first. I would actually simplify that further for my final answer. X to the third divided by x to the first would be x squared. So I would write my answer like that. All right, so number 6, pretty similar here. We have log base 5 of x squared minus 4 minus log base 5 of x minus 2. So again, just like number 5, we have subtraction of separate logs, which means we can condense it inside of one log. And now it's going to be dividing. And then this one, we're actually going to have a couple more steps here. Because if we look at this x squared minus 4 on top, That's our difference of perfect squares that we used to talk about. And so we can factor that one as x plus 2, x minus 2. And why would we want to do that? Well, we notice that when we do that, we have an x minus 2 on top and on bottom, which means we can cancel them out. So I'm going to do that in a second here, but I'm going to slow down. All right, so we cancel out the x minus 2. So we're left with log base 5 of x plus 2. There's nothing left on bottom. So there's my final answer there. All right, looking good there. Let's move on to number 7. Number 7, supposed to add them together now. So if we're adding separate logs, we can condense them as well. But instead of dividing, remember that it's multiplying. We saw this on which one? Number 4, I think, right? Yeah, remember number 4, it was adding. So we multiplied the insides of the logs, okay? So same idea here. 2 separate logs adding means we multiply inside of the log of those 2 different things. I would then go ahead and distribute into there. So 3x squared times x would be 3x to the third. 3x squared times -5 would be -15x squared. All right, next up we got number 8. So number 8 says we are subtracting these 2 functions. So we know that when we're subtracting the separate functions, we can condense them, or sorry, subtracting the separate logarithms, we can condense them, and it'll be division. All right. Then I actually notice here that on the 5x minus 15 up top, we could take out a 5. Take out a 5 means you divide both of those by 5. So this becomes just x and then minus 3. All right. Well, does that help me simplify it? I would say yes, because now what can I do? Can cancel down the x minus 3's. So I'm just left with log base 4 of 5. All right. Let's see what we got next year on numbers 9 and 10. So number 9, this one's saying to multiply these two together. I'm actually kind of okay with how that's written, but there is actually a different way we can write this. That is how the answer key wants us to write it, which is, remember we said when there's like a number out front, you can make that an exponent inside of the log. Well, even if it's not a number, we actually can still make it an exponent inside the log. So that's how they wanted us to write it. Log base 3 of x minus 1 to the power of 2x plus 2. So we did learn that in like 7.3, that if you have we always said a number multiplying in front of the log, it can move up and become an exponent. Now I'm saying, even if it's like 2x plus 2, it can go up and become the exponent. All right, and then next up, number 10, going to be kind of similar here. So this one, x plus 4 times log base 6 of x to the third. So once again, we're going to move that up and make it an exponent. But on this one, we're actually going to take it one more step further. Because when you have when like you have a base with 2 exponents like this, you can multiply those exponents together. So I'm going to say this is to the power of 3x plus 12. Okay, awesome. Now we're going to switch over and do some inverses. We did these earlier in the year, but it's been a while. So let me give you a quick reminder here. So make sure you get this down right here. So if you have something like f of 2, you're supposed to plug in 2 for x, okay? Plug in 2 for x. We don't have that here though. We have f inverse of 2. So when it's f inverse of 2, you actually still plug in 2, but not for x. You plug it in for y. We talked about inverse earlier in the year, and we always said inverse means you switch x and y, okay? So that's what we're doing now. Instead of plugging in the 2 for x, we're going to plug in the 2 for y. Now on number 11, they don't really have a y, but remember, f of x is the same thing as y, right? So when I plug in my 2 for y, it's going to look like this. 2 equals 3 times 5 to the power of x minus 1. So you see it takes over for the whole thing in front. That's like our y value is 2. And now we need to figure out what x is. So x is in the exponent, which means I'm going to have to use logs to help me solve this, okay? So this is what you guys practiced yesterday. So what we do, in this case, we would divide the 3 over. I would just leave that as a fraction. 2 over 3 equals 5 to the power of x minus 1. Then we're going to have to switch it into log form, okay? So log form, we'll have log. Remember, the base of the log is going to be the base of the exponent. So the base of my exponent here is 5. So that's going to be a log base 5. And then 2 over 3 inside of that. And then x minus 1 will be isolated. I'm going to add the 1 over. So it's going to be log base 5, 2 over 3 plus 1 equals x. Now we need to type this in the calculator. So remember to type these in the calculator. When it's a different base, we have to do log of whatever's inside the log over log of whatever the base is. All right, so I type that in the calculator. It tells me 0.7481. So I'm just going to write that. That'll be our answer. All right, so same idea here for number 12. So I'm going to plug in 5 for y. I'm going to pause there in case people are still getting caught up on 11. But if you'd like to go try to finish number 12 here, go for it. I'll start it in like 30 seconds. Okay, so if I'm going to finish number 12 here, I'm going to subtract the 2 over to this side. Five minus 2 is not a fraction, it's just 3. Now we can switch it into log form. So I'm going to say log base 2 of 3 equals x. Remember, what was the base of the exponent is now the base of the log, but it gets a new partner. So it doesn't want to be with x anymore, so it gets with 3. X is already isolated now, so I just need to type it in the calculator. But remember, I type it in the calculator as log 3 over log 2. I get 1.5850. All right, 2 more. And we'll wrap it up. All right, so number 13, similar idea here, okay? So it says f inverse of 2. So I'm going to plug in 2 for y. Now I need to isolate x. X is inside of a logarithm, and that actually means on these ones, we have to switch it to exponential form. So this is kind of the other direction. So if it starts off in exponential form, we switch it to log form. Starts off in log form, we're going to switch it to exponential form. So I'm going to rewrite it with no log as an exponential. So the base of my exponent comes from the base of the log. That's going to be 4. It still wants a new partner. It doesn't want to be with x minus 3 anymore. So the new partner is over here. It's 2. So 4 to the power of 2 equals x minus 3. Well, what's 4 squared? 16, right? And we add the 3 over. X equals 19. All right. To number 14 now. So once again, now we got the 5 in there. We'll plug in 5 for y since that's in an inverse. Okay, our variable is in the exponent. So we have to switch it. Sorry, our variable is in the log, so we have to switch it to exponential form. So the base of the exponent comes from the base of the log, so that's going to be 2. It wants a new partner. It doesn't want to be with 4x plus 1 anymore, so it's going to get with 5 now. And 4x plus 1 is over there by itself. Two to the 5th power is not 10. It's 2 times 2 times 2 times 2 times 2. So it'd be 2, 4, 8, 16, 32. Mr. Barry has all, you could use a calculator for that if you want, right? Mr. Barry has his powers of 2 memorized though. 2, 4, 8, 16, 32, 64, 128, 256, 512, 10, 24, 20, 48. So, you guys remember that iPhone game 2048? That's all the powers of 2. 2, 4, 8, 16, 32, 64, 128, 256, 512, 10, 24, 20, 48. Boom. All right, let's finish solving this. Just subtract the 1. And yeah. And so x equals 31 over 4. I would just leave that as a fraction. If you really wanted to call use the decimal, I think it's 7.75 probably, something like that. But I would just leave it as a fraction. Awesome. Okay.